This will be for the con assignment, area of a sector. So the definition of a sector, it would be a piece or portion of the area of a circle. Okay, so this is the center P right here. And if I were to draw in a central angle, it would be represented by this Greek letter theta right here. So this angle that has its vertex at the center of the circle determines what portion of the circle the sector area actually covers. So as a result, we can set up a ratio and proportion between the angles and the area. All right, so this central angle here, the measure of this angle, is represented by this Greek letter theta. And we know if you go once around the circle, that's going to be 360 degrees. And that equals A sub S, the sector area, divided by the area of the whole circle, which we know to be pi r squared. Now this setup is for when the angle measurements are in degrees, and if it's in radians, it's just one minor change. So if it's in radians, if the angle measures are in radians, you simply replace the 360 with 2 pi, because once around the circle, in terms of radians, is 2 pi. So that's equivalent to 360 degrees. A sector with a central angle measure of pi over 6 in radians has a radius of 12. What is the area of the sector? Okay, so since we're dealing with radians, I am going to use the ratio and proportion with 2 pi instead of 360. So the central angle theta is in the numerator, that's divided by 2 pi. And that equals the area of the sector divided by the area of the circle. All right. So the central angle theta is pi over 6. That goes in place of theta. And that whole thing is divided by 2 pi. The area of the sector we don't know. That's what we're looking for. And the area of the circle we can find real quick. We know that the area of a circle is pi r squared. So that's going to be pi, and the radius r is 12. So times 12 squared. Okay, 12 squared is 144, and that's times pi. So when you do the area, I suggest you leave pi as is. You leave it in terms of pi. So in place of the area, I'm going to type 144 pi. All right. Now, in order to solve for the area of the sector, since I'm dividing by 144 pi, I am going to multiply both sides by 144 pi. On the right-hand side, it cancels. On the left-hand side, this is a numerator, this is a denominator. Pi over pi cancels. 144 divided by 2 is 72. And let's see what else. This is a numerator, this is a denominator. 72 divided by 6 is 12. So everything canceled except for 12 times pi. And that equals the area of the sector. Final answer. So let's see. So it's multiple choice, 12 pi. Now, if you want to use the calculator, you can. But I suggest you cancel out the pi's at least, and then you'll have 1 pi left over if it's in radians. And you can do all of your calculations while leaving pi alone. A sector with an area of 54 pi has a radius of 9. What is the central angle measure of the sector in radians? Okay, so once again, we're dealing with radians. Okay, so it's going to be the central angle theta. And instead of 360 in the denominator, we're using 2 pi. That equals the area of the sector divided by the area of the whole circle. All right. So it said they want us to find the central angle. That would be this angle right here. Okay. So that's what we're looking for, theta. Divided by 2 pi. The area of the sector, they gave us the area of the sector, 54 pi, and you can see it in the diagram. So area of the sector is 54 pi. Area of the circle we can easily calculate. Okay, we know the area of a circle equals pi r squared. And we see that r is 9. So in place of r, we plug in 9, and that's squared. And 9 squared is 81, and that's times pi. Okay? Leave pi as is for these problems, and you'll have your area in terms of pi. So that's 81 pi. All right, solving for the angle theta. It's divided by 2 pi. The opposite of dividing by 2 pi is multiplying both sides by 2 pi. 2 pi divided by 2 pi cancels. On the right-hand side, pi divided by pi cancels. And let's see, 54 divided by 9 is 6. 81 divided by 9 is 9. And let's see, 6 divided by 3 is 2. 9 divided by 3 is 3. And in the numerator, we're left with 2 times 2, which is 4. And we still have the pi. And the denominator has the 3. So that's our central angle, 4 pi over 3. Answer D. Okay, be careful here. They tried to trick us. They have 4/3 without the pi. This is 4 pi over 3. Answer D. I'm pretty sure all of the problems that are in radians will have pi in the final answer. Okay, a sector with a radius 18 has an area of 234 pi. What is the central angle in degrees? All right, so this time, when we set up our fraction, instead of 2 pi in the denominator, we're using 360 because we're working with degrees. So that's going to be the area of the sector over the total area. All right, the central angle is what we're looking for. It's divided by 360. The area of the sector is given. It says the sector has an area of 234 pi. The area of the circle we can easily find. Area of the circle is pi r squared. That's going to be pi. The radius r is 18, so that's 18 squared. And let me calculate that. All right, 18 squared is 324. And that is times pi. So in place of the area A, we write 324 pi. All right, and theta, the central angle, is divided by 360. The opposite of that is times 360. Okay, we do that to both sides. All right, on the left-hand side, 360 over 360 cancels. On the right, pi over pi cancels. This is a little tough to reduce. Let me see if I can just do this on the calculator. 234 times 360 divided by 324. Okay, so it works out to 260. So the angle theta equals 260, and that's in degrees. All right, so once I canceled the pi's, I did 234 times 360 divided by 324, and it worked out. Usually the ones with degrees will work out to an even number. It probably won't be a fraction. So that is answer A. All right, one more. A sector with radius of 10 has a central angle of 252. We can see that in the diagram. What is the area of the sector? All right. So we have our central angle theta. And since we are working with degrees, we're going to use 360. All right, not 2 pi. And that is going to equal the area of the sector divided by the whole area. Okay, the central angle is 252, and you can see it in the diagram. So for theta, it's 252. That's divided by 360. The area of the sector, we don't know. All right, we're solving for this area in purple, by the way. That's the sector. And the area of the circle, we can easily find. That's pi r squared. We see that r is 10, so in place of r, we plug in 10, and that's squared. And 10 squared is 100, and that's still times pi. All right, leave it in terms of pi, like I keep saying for the area calculation. All right, so in place of A, we plug in 100 pi. All right, solving for the area of the sector, I'm going to multiply both sides by 100 pi. And on the right-hand side, it cancels. On the left-hand side, let's see. All right, so this one, I just did it on the calculator without reducing the fraction. Okay, I just leave the pi alone. I did 100 times 252 divided by 360, and I get 70. Okay, and I still have pi because I didn't touch it. And that equals the area of the sector. So some of them you might have to reduce fractions and cancel numerators and denominators, but in some cases you can go right to the calculator, you'll get an even number. So that's just 70 pi. All right, so it looks like there might be some problems where the answer has pi in it, even if the problem was in degrees. All right, so just be careful because they may try to trick you and have 70 as an answer without the pi. So to sum it up, you do the central angle theta divided by 360 or 2 pi, and that equals the area of the sector divided by the area of the whole circle. Okay, you use 360 if the problem is in degrees, and you use 2 pi if the problem is in radians.